Okay, so what we're about to do is we are going to continue with our vocabulary for Unit 1. On Friday we talked about variable. We talked about that X is the most common one that we use. We'll use Y a lot this year. You'll see all sorts of different ones, but definitely not O's or I's or L's because they look like zeros and ones, okay? So the next word on here is constant, okay? Constant means that it's a number that stands alone. Okay, what that means is that it does not have a variable attached to it. Okay, so a constant would be like if we had this expression right here. Which one of those would be the constant? The 4. Okay, it's important for you to pay attention to the sign that goes with that number. Okay, because let's say I have 4x minus 7. What's the constant? -7, because there's a negative sign in front of it. Okay, so it's important that you pay attention to the sign whenever you're talking about the constant. Okay, does that make sense? How that's a constant? There's no variable attached. It's never going to change. It's always going to be a positive 4. Okay, all right, when we're talking about coefficient, it's the number in front of a variable, all right? In other words, it's the number that's being multiplied by the variable. So if we use that exact same expression, 3x plus 4, what number on that expression would the coefficient be? 3. Good. Because it's the one that has the x attached. You're multiplying that 3 and that x. All right? Questions on constant or coefficient? Okay? The term, now let me tell you this, okay? There are times in my life when I was your age, when I was in high school, college, even today, that if I were to look up a definition of a word, sometimes I read that definition and I'm like, what the heck does that even mean? Does anybody ever feel that way? Okay, especially when it came to history, because I was not very good at history, and so we always, every single unit, every chapter that we did, we had to write down vocabulary words and write the definitions, and half the time I wrote it and I'm like, I have no idea what I'm talking about. Okay, so I understand this definition is going to be one of those. Okay, so we're going to write it and then we're going to break it down and talk about it individually so that it'll make more sense. Okay, so a term is a number, variable, and then it says or product or, so the third blank is quotient of a number and variable. Okay, so what we've just written is a term is a number, variable, or product or quotient of a number or variable and variable. Okay, now does that make a whole lot of sense? Yeah. Okay, so let's break it down. What does the word product mean? It's the answer to a multiplication problem, right? What does quotient mean?
It's the answer to a division.
Answer to a division problem. So what I want you to do is draw an arrow and write division. That way, if you look back at that definition, you know what that word means, okay? So, if we're looking back at this definition, it says a term is a number, okay? Somebody give me a number. 47. That's a term. Okay? The next blank says it's a variable. So, someone give me a variable.
7.
Variable. Y. I heard Y first. I heard X also. That would be fine as well. So Y would be a term. Okay, now it says product of a number and variable. So that means I need both a number and a variable. So JD, you're up. Give me a number and a variable. 5x. That's a term. Okay, and then it says or quotient of a number and variable. So we said quotient means what? Division. Okay, so that might be like what we saw on that problem of the day, that bell ringer, x over 3. Is that a division problem?
Yes.
So is that a term?
Yes.
Yes. Okay. Most of the time when we're discussing terms, they're not just going to be listed like that. There will be operations, meaning addition or subtraction between them. So for instance, like 3x squared plus 2x plus 5. Okay, so if I have this right here, how many terms is that? This one's kind of hard.
Is that 3?
It's 3 terms. What's the first term?
3.
3x squared. Okay, now here's where some people look at that and they're like, no, that's not a term because there's a squared there. Did anybody think that? It's okay if you did. Okay, so think about this. If I write 4 times 4, another way to write that is what? Not 16, but what's another way to write it more simply? 4 squared. Okay, so instead of x squared, how else could we write that? X times x. You don't have to write this stuff down unless you need it. Then you may want to do it on the back instead of like randomly like I am. Okay, does everybody understand that x squared is the same thing as x times x? Okay, so really what we have right here is 3 times x times x. Is that still a product? Yes. So that's still a term. Okay, so this is one term. This would be the second term. This would be the third term. Does everybody understand that? Okay, so this right here is 3 terms. Now, questions on terms? Anybody? Okay. Let's look at zero pair. I'm not sure if Mr. Hander used this vocabulary word last year, but once we start talking about it, you're going to know what I'm talking about. See if you can figure out what the blanks are. It says a positive and blank that add to blank. A positive and negative that add to 0. Good. Have you heard those words used together, or you just use context clues to figure it out? Do you know what context clues are? So did you use context clues to figure out those blanks? Okay. All right, so let's say I'm talking about the number -7. What would create a 0 pair? Positive 7. Because when you add those together, what does it equal? 0. Okay, what if I have the number or the term -8xy? What would be the 0 pair with that? Positive 8xy. What if I have 32.5? What's the 0 pair with it?
32.5.
Negative 32.5. Okay, so if I give you a negative, what does the other one have to be? And if I give you a positive, the other is negative. Good. All right, questions on 0 pair? Okay. Now, the last 2 are very, very similar. Okay, if you look at those 2, they both start with the word contains. Expression has blank, blank, and blank. Equation has blank, 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 and blank. Okay, now, can anyone tell me what the difference between an expression and an equation is? Peyton?
An equation has an equal sign.
Very good. An equation has an equal sign. All right, so an expression contains numbers, variables, and operations. Okay, when we say operations, that means like addition and subtraction, okay, or multiplication and division. Equations are the exact same thing, but it also has that equal sign. So these blanks are going to be the same. They contain numbers, variables, operations, and an equal sign. Okay? Now, Cannon, I want you to give me, so y'all listen because you may get called on as well. I want you to give me a term, okay, that has a coefficient and a variable. So now we're starting to use a lot of big words here. So one term, and I want a coefficient and a variable.
Okay, 3x.
Just stop there. That's what I want. 3x. Does everybody see how that's a term? Because it's the product of a number and variable. And then he gave me a coefficient, which is the number 3, and he gave me a variable, which is x. Okay? Asher, give me an operation, like addition or subtraction. Addition? Okay. Addie, give me a constant. 4. Very good. Okay, did we just create an expression?
Yes.
Yes, we did. Okay, so now what we're going to do is we're going to write that expression down here. And Lyric is going to help us turn it into an equation. So tell me what we need to add to it to make it an equation. An equal sign. Now give me a constant also, Lyric. 8. All right. Let's see. Hannah, give me an operation. Addition or subtraction? Subtraction. Okay. And Michael, give me a term that has a coefficient and a variable. Use the same variable we used before. It's something different. So instead of 3, give me a different coefficient. 7x. So did we just create an equation? Could we solve that equation?
Yes.
Okay, if not, you will be able to by the end of this class period because we're working problems just like that. Cool? All right, so what I would like for you to do now, before you move, look up here, okay? We are going to glue this on page 8. Okay, wait, I said before you move. Okay, now I want you to notice how I glue it in. I glue it so that whenever I open it, it hangs outside my journal. Okay, the reason for that is because if I were to glue it this way, and then it has to open this way, can I see any notes that have been written on page 7? Now, do I have notes on page 7 right now? No, but we may go back and add some stuff there. So I like to glue it so that it opens to the outside of my journal. Okay, so it's going on page 8. I'm going to pause the podcast while we get this glued in, and then I'll restart when we're ready. Okay, so now we're turning to pages 9 and 10 in our journal, and we are going to label them with the page numbers, and also the title is multi-step VBS. VBS in this case does not stand for Vacation Bible School. It stands for variables on both sides. Okay, but instead of having to write multi-step equations with variables on both sides, we're abbreviating VBS. Okay, so multi-step VBS, you're going to write that on both 9 and 10 at the top. Okay, and you can go ahead and write this that I have on page 9 as well. Okay, so what we're going to be doing today is we're going to be working some examples like that very last equation that we created, also like the one that's on the board right now. With the very first example, we're going to write down some steps over here to help us understand what we're doing as we work it, okay? I'm actually going to be working it on the smartboard and not in my journal, but I want you to see how the journal should be set up right now, okay? So this would be page 9 in your journal. All right, so this is where I'm going to be working the examples today. So like I said, we're going to be writing some steps. Now, hopefully this, I know this sounds crazy. I normally do not want the lesson to be boring, but hopefully today it's a little bit boring because you remember it from last year, okay? This should be review from last year, but I do have some students that either didn't attend Denison last year or didn't have Mr. Hander last year, so we're going to kind of work some examples to make sure that everybody understands how to do these problems, okay? So as we're working the example, like I said, we're going to write down some steps, okay? And those steps are going to tell us what we're going to be doing next, all right? So we're going to write this step, and then we're going to actually work it in that example problem, okay? All right, so step 1, again, this may be a little bit different than Mr. Hander, so let me show you. Put your pencils down for just a second because I don't want you writing while we're talking. But let's talk about this and then I'll let you write it. Okay, step 1 says to get your variables on the same side. So let me ask you this. Do you remember which variable Mr. Hander told you to move first?
The small one.
Why? Do you remember why it was the smaller one that was the better choice?
No.
You remember, Peyton? Because then I don't have to deal with the negative. Okay, so look up here again at this example. Which one of those variables has the smaller coefficient? Negative 2x, right? Okay, so if I were to move the 4x instead, what would I end up with over here? A negative 6x. So by moving the bigger one, I've created not necessarily more work, but maybe a little bit more difficult problem because now we're having to think about a negative number. Does that make sense? If we move the negative 2x to the other side, what am I going to have? A positive 6x. And so now it's a little bit easier to work with. Does that make sense? Okay, so go ahead and write step 1 in your journal. Get your variables on the same side. So just write the step, and then we're going to work it together. Okay, so today we're only working 3 problems, but we're going to take up both pages 9 and 10, so please don't try to cram it all on one page. Take up as much room as you need to, okay? Because we're doing 3 problems across 2 pages, all right? All right, so we're going to get our variables on the same side. Before we do that, according to the people that came in before you today, they said that Mr. Hander had you do the same thing that I want you to do. Can you remember what you're supposed to do before you start moving stuff around? No, before we do any kind of work. Draw a line. Where are we drawing that line?
Under.
Through the equal sign. Do you remember why we draw the line through the equal sign?
So that it's easier.
It helps us separate the sides so we're not trying to do too much on one side. Okay, now for those of you that maybe don't remember doing this last year, here's the example I always use. You can put your pencils back down for a minute. Okay, so I hate grocery shopping alone. Okay, not because I don't want to be at the store by myself, because that doesn't bother me. The reason I hate grocery shopping alone is because it means that my husband isn't home to go with me, which means not only do I have to do the shopping by myself, I have to unload the groceries by myself, and then I have to put them away by myself. Do you see what I'm saying? So when that happens, I try to avoid it. Like yesterday afternoon, we went to the store together, so then he had to help me carry stuff in and put it away. All right, but if I have to go alone, I would rather get all of the groceries in one trip and break my arms than to make multiple trips. Does anybody else see that? Like, you get as many things as you can because you don't want to have to go back outside, especially when it's like 500 degrees outside. Okay, so when you do that, it's best if you get like an equal weight in each hand, right? Okay, so let's say I'm walking in with the same amount of weight in each hand. I'm balanced, right? Because I don't want to be walking like leaning to one side or the other because then it's going to hurt my back. So I'm walking in balance. I have the same amount in each hand. Okay. Now let's say Cannon like runs into me and I drop a bag of cans on his toes. Okay. I drop them out of my right hand, so now my left hand is a little bit heavier. So if I'm wanting to balance myself back out, what do I need to do?
Pick it up.
Drop that same number out of the other hand, right? So if I'm dropping something out of one hand, I want to drop something out of the other hand. Now, if I do choose to bend down and pick it back up with my right hand, what do I now need to do with my left hand? Bend down and pick it back up. Does that make sense? Because you want to stay balanced, okay? Same thing with equations. You want to stay balanced. So if I move something from the left side, what do I need to do? The same thing on the right side. Okay, so which variable did we say was the smallest? The negative 2x. Okay, how are we going to move that negative 2x to the other side? By adding, because we're trying to get a, what's that vocab word we talked about today? It's a 2-word vocab. Zero pair. Okay, so whenever I add 2x, what have I created right here? A 0 pair. Now, whenever I add it to the right side, is this where I'm wanting to write it? Why not? Right. 24 doesn't have a variable. So can I add 2x to 24? No. What am I wanting to add it to? The 4x. So I'm going to line it up underneath the 4x. Okay, like we said, this is a zero pair. So what's left on the left-hand side? Negative 12. And on the right side, what do I have now?
6x plus 24.
6x plus 24. Good. Now this looks kind of like a problem we did a little while ago for our bell ringer, right?
Yes.
Okay, so now my variables are on the same side. Step 2 is to undo addition or subtraction. So in this problem, which one of those do we have? Do we have addition or subtraction right now?
We have addition.
We have addition. So how are we going to undo that addition?
By subtracting it out.
By subtracting. So what is it that I'm going to subtract?
24.
The 24. Because what's my goal for this problem? I'm trying to get x by itself, right? So I'm trying to move everything so that it's away from the x. Now what have we created right here? A zero pair. What's left on the right side?
6x.
6x. Now on the left side, we have to remember our integer operations. Okay, right now they have the same sign, so what do I do with the numbers? Add them together, and what do I do with that sign? Do I keep it or change it? It stays the same. So think about it this way, okay? Before you keep writing, think about this. It's like you owe $12, and now you owe 24 more. So do you magically now have positive $36 in your wallet? No, how much do you have?
Negative 36.
Negative 36. It would be nice if you magically had $36 in your wallet. Okay? Everybody good with that step? How many of you remember doing this last year? Okay, good. All right. Step 3 is to undo multiplication and division. All right. So, in this problem, which one do we have? Do we have multiplication or division? Right now, what is it? It's multiplication. So to get rid of it, I'm going to divide. Okay? What is it that I'm going to divide by? 6. And why am I dividing by 6?
To get just the x.
To get x by itself. Here's a trick question. What did we just create right here? Oh, I said it was a trick question. Does it give me 0? What's 6 divided by 6? 1. So I just have 1x. That's not called a zero pair because it doesn't add to 0. All right. Now I have a negative divided by a positive, which gives me what? A negative. And what's 36 divided by 6?
6.
So my answer is
6x.
I messed up.
negative 6. All right, listen. Are we done?
No.
It's another trick question. What do you think I'm going to require you to do next? Check your answer. That's step 4. Okay, now I know that at least what third period said was last year, if Mr. Hander told you to check your answer, he said that you could use a calculator. Not today. Not in my class. There will be days where I'll tell you that you can use a calculator to check it, but today we're actually going to work it out. Okay, now let me show you why. Okay, you do have homework tonight. It's only 8 problems. And it looks like this. Okay, so it's 8 problems, but there are 16 boxes. Okay, so what you're going to do is you're going to solve in this box, and then you're going to come over to this box and check your answer. Solve here, check here. Does everybody see that? So you're going to solve 8 problems, and you're going to check 8 problems. If you come in tomorrow and all you've done is solved, guess what you get? Nope, you get a 0 because you didn't follow directions. Okay, if I wanted you to only solve, what would I have assigned? Solve. Am I assigning only solve?
No.
What am I assigning?
Check
Solve
and
and
check.
check. Okay, so make sure that you do all of that on your assignment tonight. Okay, so let me show you what I want to see on your check step. Okay. All right. Now, some of you may remember how to check. Does anybody remember how to check?
No.
Okay. What are we gonna do?
You put the negative 6, which is x, you put it in the x spot on the right equation.
Right. Okay, so we just said that x is negative 6, right? So we're going to take that negative 6 and plug it in to the original equation. What I like to do is I like to rewrite that equation Now, not everyone likes to rewrite the equation. That means one of two things. You either are lazy or you think that you're going to die from that little bit of extra work. Okay? There should be plenty of room in your journal for you to write that equation. The reason I like to write it is this. If you don't, chances are you're going to leave off a negative somewhere along the way. Okay? So you're more likely to be consistent and correct if you rewrite it. Okay, now what did we say we were going to put in for x?
-6.
-6. Okay, again, I'm going to draw the line just so I don't like start getting crazy and moving stuff around. Okay, so right here I have -2 times -6. Is it a positive or a negative? A positive what? 12. And then I have -12 equals, I have a positive 4 times a -6, -24, and then I have a positive 24. Now I have 12 minus 12 is 0. And sorry, that's a 0, not a 6. 0. And then I have -24 plus 24. 0. Is this a true statement?
No.
So is our answer correct? Yes.
Yes, 0 does equal 0.
All right. Any questions on this problem? Okay. Let's look at this one next. If you have room at the bottom of page 9, you can work it there. If not, move on to page 10. It's no big deal. Okay? Don't try to like squeeze it though, because you've got two. We're only doing this problem and one more, so you've got plenty of space on page 10 if you need it. Okay? All right. Has everybody written it down?
No, ma'am.
Okay. Write it down and draw your line. What was step 1?
Same side.
It's to get our variables on the same side. Which variable do we want to move, Samantha? Why do you want to move the 3x? It's smaller and it's going to avoid a negative. Good. All right, so how are we going to move that 3x, Danielle? And why are we subtracting it? It's positive right now, and what is it going to create? What's our new word? Starts with a Z. It's a 0 pair. So if I subtract 3x from the left side, Kaylee, what do I need to do on the right side? And where am I going to write that minus 3x?
Under the 7.
Very good. Underneath the 7x. Okay, so Danielle told us that this is a 0 pair. What's left on the left side?
-7.
-7. And Lyric, what am I going to have on the right side now? 4x and what else? Good. Okay, what does step 3 say to do, Addie? Okay, so we're undoing addition and subtraction, right? And so how are we going to get rid of the 23? By subtracting, because right now it's a positive, oops, and we're trying to create a 0 pair, right? Okay, JD, what's left? 4x, and what is the left side going to be?
30.
Positive or negative?
Negative.
Good. -30. Okay? All right, Peyton, what do we do next?
You divide by 4.
Why are we going to divide by 4?
Because you gotta get the x by itself.
We're getting x by itself, and when it says 4x pushed together, what does that mean?
It's
It's the
the coefficient.
coefficient. It means you're multiplying. Good. So we're going to divide by 4. Is that going to give us a nice, pretty whole number?
No.
No. What is it going to give us?
7.5.
What kind of 7.5?
Negative.
-7.5. Now, I will tell you this. If I remember correctly, it's like I worked this last week sometime. I don't think there are any decimal answers on your homework. I could be wrong, but I don't think that there are. Okay? I'm not going to make you check this problem just for the sake of time. The next problem you're going to do on your own and you're going to check it. All right, is everybody ready for that one? Okay. Go ahead and work this one on your own and check it, please. Okay. I'm going to move the 8p because it's the smaller one, and I'm going to subtract it so that I get a 0 pair. So on the right side, I now have -1, and on the left side, I have -2 plus 2p. I'm trying to get p by itself, so I'm going to undo this. Even though it shows addition right here, I'm trying to undo this negative number right here, so I'm going to add 2 to both sides, which gives me 2p equals 1. And then when I undo that multiplication by dividing by 2, what do I get that p equals? 1/2 or 0.5. Either way is fine. Okay? Again, I want you to check this one. It doesn't matter whether you plug it in as half or as a decimal. You'll get the same answer either way. So right here I have half of 10, which gives me what? 5. And then I have half of 8, which gives me 4. Now I have -2 plus 5, which gives me what? +3. And then I have 4 minus 1, which gives me +3. Does 3 equal 3?
Yeah.
So did we do it right?
Yes.
Yes.